Chapter 16, Oxidation and Reduction. We've talked about oxidation-reduction reactions in an earlier chapter, and we're going to talk now about them in a little more detail. There's different ways to define what oxidation and reduction are. One definition, which is really the origination of the word oxidation, is that when something is oxidized, it gains oxygen. And so if we look at something like iron rusting, we see that the iron reacts with oxygen to become an iron oxide. The iron has gained oxygen. That is oxidation. That's an example of a slow oxidation. Rapid oxidation would be something like a combustion. Here's methane, natural gas. Here we see that the carbon does not have any oxygen attached to it, and after burning in the presence of oxygen, we form carbon dioxide. It now has oxygen. It has gained oxygen. It has been oxidized. So that's one way. That's not the best definition, but it is a definition that oxidation is the gaining of oxygen. And then reduction, which is the opposite of oxidation, must be the loss of oxygen. Another way is in terms of electrons. Now, if we look at this equation, chemical equation, lithium plus oxygen to form lithium oxide, we see that the lithium is gaining oxygen, right? Let's look at what's happening with these elements. Here we've got lithium atoms that have no charge, and here we have an oxygen molecule, and that has no charge. Over here in this product, we have lithium ions and oxide ions, because that's what an ionic compound is. We've got lithium ions and oxide ions, and so these have a positive charge, these have a negative charge. How does an atom turn into an ion? Gaining or losing electrons. So if we look at lithium, which we understood by its reaction with oxygen to have oxidized, did lithium gain or lose electrons to become Li+? It lost them because electrons are negatively charged. So in this process, lithium loses one electron. The oxygen became O2 minus by gaining electrons. So each oxygen gained 2 electrons. So another way to define oxidation, oxidation is the loss of electrons. So here, lithium lost electrons to become lithium ion. It was oxidized. Reduction is the gain of electrons. So oxygen gained electrons, the oxygen was reduced. You have to have oxidation and reduction occurring together, because there's no electron bank where an atom can go and just withdraw electrons. There's no, donation station where if you've got extra electrons, you can just throw them in the box in the corner of the parking lot. They have to come from another atom, so they always go together. If one substance loses electrons, which is oxidation, then another substance must gain the electrons. So they're always together. Let's look at this reaction here. Here we've got hydrogen reacting with oxygen to form water. Is the hydrogen being oxidized or reduced? Oxidized. That first definition where oxidation is gaining oxygen. Here, the hydrogen is gaining oxygen, so the hydrogen is being oxidized. The hydrogen's being oxidized Now this is confusing. That makes it a reducing agent. The reducing agent causes the reduction of something else. It gets oxidized in the process. So let's think about the movie industry. Movie stars have agents, right? Do the agents act in the films? No. But the agents get the parts for the actors to act in, right? So the agent doesn't do the acting, but the agent causes that to happen. So a reducing agent is like a movie agent. It causes something to be reduced. Okay, so reducing agent causes the reduction. Itself, it is oxidized. In this reaction, oxygen is reduced. It is the oxidizing agent. The oxidizing agent causes the oxidation of another substance. It does not get oxidized itself. That's confusing, isn't it? There's all these pairs of things: oxidation, reduction, cations, anions, gaining, losing. You have to come up with a way that you can picture it in your mind. I'm trying to share my pictures with you. They may or may not make sense for you. So here's a summary. This can help in remembering which is which. Oil rig. So this is an acronym. Oxidation is loss of electrons. Reduction is gain of electrons. And I say that to myself a lot when I'm trying to remember which is which, because I don't deal with oxidation and reduction on a daily basis, and so I tend to just kind of forget a little bit. I say oil rig. Oxidation is loss of electrons. Reduction is gain of electrons. So an oxidation is the loss of electrons. A reduction is the gain of electrons. An oxidizing agent causes something else to be oxidized, so it is reduced. The reducing agent causes something else to be oxidized. The reducing agent causes something else to be reduced. The reducing agent is oxidized. So if we go back, well, we don't need to go back to that. Any questions? Let's look at an example here. Just identifying oxidation and reduction. So the question says to identify the substance being oxidized and the substance being reduced in each reaction. So this first one, there's no oxygen in here, right, to look and see what's gaining oxygen. So we need to use the definition in terms of electrons. So our product here is an ionic compound. What kind of an ion does potassium form? A +1. And chloride has what charge? -1. So here we had two elements, potassium and chlorine. The potassium went from a 0 charge to a +1 charge. Is that losing electrons or gaining electrons? Losing. Oxidation is loss of electrons. So the potassium is being oxidized. That's the one that's being oxidized. The chlorine went from 0 charge to a -1 charge. Is that losing or gaining electrons? Gaining. Reduction is gaining. Reduction is gaining. So the chlorine is being reduced. Does that make sense? Let's look at this next one. So we've got aluminum plus tin 2 ion, and it's going to aluminum ion plus tin metal. Which one is losing electrons? The aluminum, because it went from a 0 charge to a +3 charge. The number of protons always stays the same, and so to become a positively charged ion, you have to lose some of the electrons that are balancing that charge. So the aluminum then is being oxidized. I'm just going to call him ox. What's happening to the tin 2? Reduction, it's gaining electrons to go from a positively charged ion to a neutral element. So this is reduced.
Those would be the agents.
No, this is being oxidized, and this one is being reduced. Well, there are agents, but we're going to talk about the agents on the next slide. How about this one? We can't look at ions here, because carbon dioxide is not ionic. But we see there's oxygen in there. We see that the carbon is gaining oxygen. Gaining oxygen is oxidation. So the carbon is being oxidized. Something has to be reduced. It's going to be the other thing. So that's being reduced. You see how to do that? Now we're going to look at the same equations, but identify the oxidizing agent and the reducing agent. So let's just refresh our memories a little bit. In all three of these examples, the species being oxidized was first. So let's look at this in terms of agents. So we said before that the potassium was being oxidized. That means it's the reducing agent because it is causing the chlorine to be reduced. So the potassium is, oh, I did it again. Reducing agent. That makes the chlorine the oxidizing agent. The chlorine is being reduced. It is causing the other thing to be oxidized. Just like an agent causes someone else to get a part in a movie, right? He goes out and negotiates and makes it happen, but he doesn't actually act in the movie. The oxidizing agent does not get oxidized. He causes someone else to be oxidized. So here we've got aluminum going from Al to Al3+, loss of electrons. It is being oxidized. So it's the reducing agent. This other one is the oxidizing agent. The tin-2 ion is causing the aluminum to be oxidized. In this reaction, we said that carbon was being oxidized, that oxygen was being reduced. The oxygen then is the oxidizing agent. The carbon is the reducing agent. Any questions?
So would it always be opposite?
Yeah, they're always going to be opposite. Yeah, so the oxidizing agent is the one that gets reduced. The reducing agent is the one that gets oxidized. And reduction is gain of electrons, oxidation is loss of electrons.